Hey y'all, today we're going to talk about solving equations with variables on both sides. And we'll also talk about one solution, no solution, and infinitely many solutions. So today you guys will need your note packet and we'll be on page 5 and 6. You will also need your calculator or the online calculator that's on my website. So we will go ahead and go to page 5 and 6. All right, so this is just kind of like a little intro. I know you guys did it last year in pre-algebra, but Keisha modeled an equation x minus 3 equal to negative 2x's plus 5. So I just want you guys to write down anything that you notice. How can Keisha collect the variables on one side of the equation? And then how could Keisha collect the constants on one side of the equation? Just write a little something, pause it for a second, and then hit on pause whenever you guys are done. Okay, something that I noticed was that there were like the X bars on both sides. Some were positive and some were negative on both sides. That's something that I just noticed. How could I collect the variables on one side? Well, if I wanted these to go away, I would have to use some positive X bars to make them disappear. And I would have to kind of do the same thing with the constants. So it's okay if you didn't have anything written, if you thought about it, don't have to write anything down, just kind of get in your brain ready to go. All right, so here are the steps to solve equations with variables on both sides. We do this after we do multi-step equations because, of course, the first thing that we need to do is we need to distribute if needed and or combine like terms. Okay. After that, we will need to collect the variables on one side of the equal sign. And I always like to put a little plus minus sign because the way we do that is by either adding or subtracting. Then after that, we will collect the constants or the regular numbers. That's what I mean by constants, just your regular numbers with no variables on one side as well. Again, we will do that with adding or subtracting. And then we will just solve an equation like we know how to do. So let's go ahead and get started. And then you guys will go ahead and just try it out. All right. It says to solve the equation, and then we will also check to see if we're getting these right. All right, so we have 11x minus 8, and we want to see when is that equal to negative 7x plus 64. So there's more than one way to do it. Me personally, I don't like to deal with negatives if I can help it. And so I don't see any distributing. I don't see any combining like terms on this side or on this side. So we need to basically collect the variables onto one specific side. If I'm teaching this to my 8th graders, sometimes I'll just say always to put it on your left because that's the way we usually like to see it. But I like to not have any negatives. So I will always undo or reverse any negatives. So I'm going to get rid of this negative 7x. The way I'm going to do that is with a positive 7x. Okay. When that happens, negative 7x and a positive 7x zero out to nothing. So all I'm left really on this side of the equal sign is a 64. Okay. I still have this negative 8, but now I have 11 x's with 7 more x's, and I get 18 x's. All right, from there, then I'm going to, this is just basically like a two-step equation. I'm going to undo the constant. So the opposite of a negative 8 is a positive 8. This would make a 0, 64, and 8 makes 72. And the final step would be basically just to get the coefficients away. So I will divide by 18. 72 divided by 18 is 4. So if we are right when we check, we should see that 4 works. So we will check our work by basically writing the original equation. But instead of x, we're checking to see if 4 is the right answer. Okay. 11 times 4 is 44. 44 minus 8 is 36. I just wanted to make sure. Okay. So if we are right, the other side should also equal 36. So we have negative 7 times 4, which would be negative 28. And negative 28 and a positive 64 also make 36. So we are correct because both of them are equal to each other. All right, so number 2, this has a little bit of distributing in it, so just making it a little bit more challenging, but nothing too crazy. So first we are going to distribute the 5. 5 times 2 is 10. 5 times negative 3 is negative 15. Okay. And again, there's more than one way to do these problems. You could move this 10x over to the left side with subtraction. Again, me personally, I don't like negatives if I can help it, so I'm actually going to move this negative 2x. The opposite of a negative 2x would be a positive 2x. When I do that, negative 2 and positive 2 make a 0 pair. 10 and 2 make 12 x's. And then from here, I'm just going to work my way out, and I'm going to basically get x over onto this side. So I'm going to get rid of a negative 15. Divide by 12, and I get 2 equaling x. Again, I just like to rewrite it because that's how I like to see it. And so I get x equals 2. So if I am right, we should check our work. We should get the right answer. So we're checking the number 2, 2, 2. So negative 2 and 2 make negative 4. Negative 4 and 9 make 5. So if we're right, the right-hand side should also equal 5. Okay, so we have this stuff in parentheses. So we're going to do 2 times 2 first. 4 minus 3 is 1. 5 times 5 is 5. 5 times 1 is 5. So they are both equal to 5. So we know we got it right. All right. So now what I want you guys to try is I want you guys to try 3, 4, and 5. Go ahead and pause the video. Whenever you guys feel like you have your answers for numbers 3, 4, and 5, hit unpause, and then I will show you guys the answers. All right, so for number 3, I got the answer of k equaling negative 86. For number 4, I got h equaling 2.5. And for number 5, I got n equaling 2. Okay? So if you guys got those right, you guys can just keep going. At the end of this video, if you guys got one of these wrong or you wanted to just kind of see the process that I did it, just wait till the end of the video and I'll come back and we'll watch this. Okay. So now on the back page, on page 6, we're going to talk about different solutions. So first, it just says to solve the equations outright, and then what do you notice? Okay, so for this first one, we are just going to distribute like normal. 4 times 2 is 8. 4 times negative 4 is negative 16. Okay. Now, if you notice something now, that's awesome. That's usually what I will notice, but if I don't, I'm just going to keep going. I'm going to get rid of this 8x. That makes a 0, but that also makes a 0, which is like super duper weird. So then we're just left with negative 16 equaling 3, and that makes just no sense. What in the world is that? So we'll talk about what that means in a second if you don't already remember it. Okay. Then over here on this problem, we have distributing as well. Negative 2 and 5 make negative 10. Negative 2 and negative 8 make a positive 16. Again, if you notice something now, that's awesome. That's what we kind of want to get to. But if not, let's just keep on going. Okay, we have a negative 10x. So we're going to get rid of that with a positive 10x. Okay, well, that makes a 0. That makes a 0, which is weird. And then we're just left with 16 equaling 16. And we're like, whoa, that makes that does at least make sense. So each of these two problems means something. You guys talked about it in pre-algebra, but now we're just going to kind of refresh our brains a little bit because we'll talk about this a lot throughout the entire year. Okay, so we have 3 different types of solutions. So when you first in 6th and 7th grade, you guys talked about solving an equation, there's usually always one answer. That's what we usually start with, one answer. There's just one value that makes the equation true. So that would be something like 2x plus 1 equaling 5. Okay, there's just one answer to that one. Okay, and the answer would be 2. Just so you know. Okay. Then something like this problem, we had the same variables on both sides, but we had different constants. We had different numbers, and that makes no sense. Negative 16 is never going to equal 3. So when that happens, we actually have no solution. Okay. There is not a value that will ever make this equation true. There will never be a math problem that you can put into this x and also put into this x and multiply it by 8 and it be the same thing as subtracting 16 and adding 3. It doesn't make any sense, and there's never going to be an answer to it. Okay, so this would be an example, like we'll just write what they have. That's an A, by the way. Something that maybe you do notice is that those are the same, but those are different. So as we start doing these problems, if you notice those little things, you don't have to finish the problem. You could actually stop right there and say, oh, well, the variables are the same, but the constants are different. That makes no sense. It's no solution. And you can actually stop right there. Okay? All right, and then the very last problem, which is very similar to this one, it was the exact same thing. It was negative 10x plus 16 equaling negative 10x plus 16. And what that means, guys, is you could put every number in the entire world, except for all real numbers, I guess. You could put this into the x and into the x, and it would equal each other. It doesn't matter. It doesn't have to be 2 or nothing. Like, there is always going to be an answer to it. So we call that all real numbers. Okay? And so that would be any real number will make this equation true. So we call that, I usually call it just infinite solutions. Okay, an example would be something like 5x plus 1 equaling 5x plus 1. Okay, and there is a trick. I mean, guys, if you notice that everything is the same, okay, you don't really have to do anything else to this math problem. If you notice that the variables are the same and the constants are the same as well, you could just stop right there and say, whoa, it's infinite number of solutions, or it's all real numbers. Okay? All right. So now basically we're just going to practice a few, just make sure you guys feel good with this, and then you guys are just going to practice a little bit independently. Okay, so we just have some solving basic equations. First, we are going to, I see distributing, so we're going to distribute. This is 7. Negative 0.5 times 10 would be negative 5. Negative 0.5 times negative 4 would be a positive 2. Then from there, I'm going to combine like terms. So over on this left side, I see a 7 and a 2, which would make 9. Okay. Over on this side, I see a 3 and a 6, which would make 9. Then I look at the problem, and I look at it before I go on to the next step, and I notice that these are the exact same problems. Left side's the same as the right side. Okay, so that means that there are an infinite number of answers. I could put any number into this x and it would work. So we could just stop. That doesn't look good. I could just write infinite solutions and be done. Okay. All right, the next problem, we have a lot of distributing going on. So we are going to distribute. Okay, again, there's not a number that's in front, but there's a negative sign. So we'll distribute a negative or a -1. So we should get -14. A negative and a negative make it positive. And then we are going to distribute the 4 to 2c and to 5. All right, I can go ahead and I can look at this and I can say, okay, I have different variables, different amounts on both sides. So I know that there's going to be an answer. And now we need to figure out what that answer is. So we'll just keep going how we know how to do it. So I'm going to move the smaller amount over to the bigger amount. So the opposite of a positive 8c is a negative 8c. 9 minus 8 is 1. Now I can just move the constant. The opposite of a -14 is a positive 14.
Oh, I flipped classroom.
Hi, Corey. All right, and then you have 1c. If you want to divide by 1, you can, but the answer is still just 34. It has one answer. All right, and then the last problem we are going to do together is this one. So we have just some distributing. So we're going to distribute -0.75 times 12. -9. -0.75 times 60. Got -45. All right, now I'm going to look and see if I can combine like terms. There's nothing over there that I can combine, but there's some stuff over here I can combine. -x and a -8x would be -9x. Then from here I can look at the problem and I notice that the -9x's are the same, but the constants are different. So I actually could stop here if I know my rule of if the variables are the same but the constants are different. This is actually no solution. Because there will never be a time that -45 will ever equal -15. All right, so if you guys got the problems correct up on page 5, without me showing you guys can go on to the assignment. The assignment is on Go Formative. It will be on Google Classroom, so you can just follow the link there. Okay, if you want me to go through 3, 4, and 5, just stay on and we'll go through those real quick. Okay, so for number 3, we have a lot of distributing going on, so we're going to distribute. We have 5k. 5 times 14 would be 70. Okay. Then we're going to distribute a fraction. Okay, if you need help multiplying a fraction into your calculator, okay, again, you're going to hit the alpha button and then the y equals button, and a little fraction, like the options of your fractions will pop up. So I'm going to hit enter and I'm going to type in 1/5. Okay. And then I'm going to hit times 20. And I get 4. And then I'm going to do the same thing for 1/5 times -80. And I get 16. All right, now I look and see if I can combine anything. Nope. Combine anything? Nope. So I'm going to just solve this equation. So I'm going to move the smaller amount of k's in this case over. So I'm going to subtract 4 k's. Should make 0. 1k plus 70 equals -16. Now I'm going to subtract 70. So that would make a 0. And I have 1k equaling -86. You can divide by 1 if you want, but that is how I got the answer of negative 86. All right, for number 4, we have some distributing going on. So we're going to distribute first a negative 8. Okay. So I have 2 minus 1.6h plus 8. And I notice that I can combine the 2 and the 8 together, which would make 10. I can't combine those together, so I'm just going to rewrite it. All right. So now I'm going to move, again, me personally, I like to move the smaller amount. So I'm actually going to move this negative over with this positive. So the opposite of a negative would be a positive 1.6h. I'll make a 0. And that would be 6.1h. Okay, now I'm just going to move the constant negative 2.7 over 5 over with a positive 2.75, which would be 12.75 and 6.1h. Now I'm going to divide by 6.1, 6.1, if I'm right. Nope, did something wrong. Oh, it's 5.1, I'm silly. So this should have been a 5.1. Okay. This should have been a 5.1h when I added them together. So then I should have divided by 5.1. So 12.75 divided by 5.1 is 2.5. All right, and then for the last problem, we have some distributing to start off with. So we're going to distribute the negative to 8 minus 2n. So we would have negative 8, and we would have a positive 2n. Then we're going to distribute the negative 2 to 12 minus 3n. So that would be negative 24 plus 6n. Now I'm going to combine like terms. None of those can be combined, but I look and I see 8 and negative 24. And that would be negative 16. Yeah, negative 16. So now we need to get the variable on one side. Me personally, I'm going to move the smaller amount. So I'm going to subtract 2 n's. Now I'm going to move the constant with a positive. So that would be a positive 8 equal to 4n. And then finally, we just divide by 2. We get by 4, and we get 2. All right, so now I want you guys to practice on the Go Formative, and the directions are on Google Classroom.